learn about a new kind of, or rather a different kind of optical instrument, astronomical telescope. What exactly is the use of this device? Till now, we have been magnifying the visual angle, and that is for objects close to us. But let's say we want to observe star or sun or anything for that matter which is a very far distance away from us. I cannot use microscope, simple or compound, because what I do is I keep the object close to the objective in both the scenarios, close to the lens. And my object is now far away from it, so I cannot use the microscope for it. So I'll have to use a different device, and that device is telescope. And to be specific, we'll be dealing only with the astronomical telescope. See, telescopes are of two kinds: refracting kind, reflecting kind. Now, reflecting kind of a telescope is based on some kind of a diagram in which you have a mirror over here and a mirror over here, and then rays come and they perform something like a periscope kind of an adjustment. And you don't have to go to the analytical description on how a reflecting type telescope works. Just understand that there is something as reflecting kind of a telescope too, and what we're dealing with is, from your level, from your perspective, is only the refracting kind, the more popular kind and the more prevalent kind of telescope. Now let's start astronomical telescope. So in this astronomical telescope, we have an objective having large aperture and large focal length, and an eyepiece having a smaller aperture and a smaller focal length compared to the objective. So let's make an objective over here. Now, this is the optical center of the objective. Let's say the object to be seen is at a very far away distance, at infinity, and close to the principal axis. So let's say this is your object P, Q. So the rays would come like this. At some angle to the principal axis. That angle would be alpha. The same angle will be subtended over here, alpha. Now, this would further go like this. This ray would converge over here. So now you have P prime or P dash. This is Q prime or Q dash. Now these rays further proceed ahead. Like this. And this is where they meet the eyepiece. It kind of looks like the eyepiece is having a larger aperture and larger focal length, but it's not the situation. The eyepiece generally has a smaller aperture and a smaller focal length. Now, again I have two scenarios. One, my eye over here perceives that the rays are parallel to me, or they're not parallel. If they're not parallel, again the case of least distance of distinct vision. I'm drawing that scenario now. So that gives you this. Essentially this thing over here. these two lines are in the same line essentially. This is your P double prime or double dash, Q double prime. Now, this is the diagram of astronomical telescope which we're dealing with. And over here, you understand that the eyepiece, which is closer to the eye, is of a smaller aperture, smaller focal length. This looks like a larger lens, but this is smaller essentially. What I'm doing over here is this alpha, which you see here, is also the alpha observed when there's no arrangement over here. Why? Because if this is very far away, then even your eye would perceive this object subtending an angle alpha, right? So I can say that mod of alpha is equal to, rather approximately equal to, mod of tan alpha, because alpha is very small, and that would be equal to just magnitudes of height upon base for alpha. That would be in this scenario P dash Q dash upon this length over here, right? What is that length? That length is equal to, if you are careful enough, you'll understand this essentially is the focal length of the objective. Why? Because parallel rays after converging meet at the focal point. So this has to be the focal length. So this is your F naught. Now I will see this as my beta, right? And this is the magnification produced by this instrument. What would be beta? Mod beta essentially approximately equal to tan beta. This is your P dash Q dash upon EP dash. That makes perfect sense. Now, if you divide these two angles, the ratio of the visual angle gives the ratio of magnification required. So, M over here would be just mod beta by mod alpha with the sign, necessary sign over here. Because see, alpha was in this sense clockwise and beta is in the anti-clockwise sense. So, it means that the beta by alpha should be with a negative sign because magnification is produced in the opposite sense. So, magnification over here would be equal to minus mod of beta by alpha, which essentially is your P dash Q dash would be cancelled away, F naught would come over here. So, this would be equal to F naught upon your EP dash with a negative sign. What I need to find out now is the negative EP dash value. And I have told you that two situations are possible. One, the case when the eye is under least strain, the normal adjustment case, and the case when the eye is under the maximum strain or the least distance of clear vision strain, which is the situation in this diagram. And if my rays would, these rays are not parallel essentially. Eye is perceiving them to be coming from these two paths. If these are parallel, I'll have normal adjustment, right? For normal adjustment, what would happen is your EP dash should be focal length of the eyepiece, only then the rays would be parallel to you, you will perceiving them parallel. So EP dash has to be f of E for normal adjustment. I hope this makes sense, right? I mean, if again I'll repeat, you're not trying to understand, then you're losing a lot, because this is very easy, and if you master this, you'll never find optics boring. And if you don't master this particular region of geometrical optics, you'll always find it troublesome. You have to know what are the necessary approximations to be made. So this is a learning curve which you have to go through. So if you have any trouble, just go through it again. So in the normal adjustment thing, EP dash is FE. Let's put that over here. So M comes out to be minus FO by FE. And this is for your normal adjustment. I mean, when the object is in such a way, the image is perceived to be at infinity from the eye. Now, what would be the length of the tube in such scenario? In such scenario, your EP dash plus FO is the length. You know, always, actually, it is always the length of the tube. Length of the tube is equal to FO plus EP dash. And for the case of normal adjustment, length of the tube becomes FO and EP dash is equal to FE. This is length of the tube and magnification for your normal adjustment. Now let's talk about the thing of this diagram. When my eyes are perceiving the image of the object to be at this position. So this length over here, this guy over here is your D. Just magnitude wise, least distance of distinct vision. And this thing is your EP dash, and the focal length of eyepiece is FE. So I can comfortably write 1 by V minus 1 by U is equal to 1 by F. What is F? F is FE. Just write it over here. What is V? V is minus T because it is on the left hand side. Write that value down. What is U? U is EP dash. Write that thing down. Not normal EP dash, minus EP dash, because the left hand side. FE. What I need is EP dash. Let's find that out. Your 1 upon EP dash minus because plus would be equal to 1 by D plus 1 by FE. If you further simplify it, you will get D FE over here and FE plus T over here. Invert it through, your EP dash would become FED times FE plus T. Now, do I need EP dash? I actually need 1 upon EP dash, right? That should make perfect sense to you. So, if I need 1 upon EP dash, I need minus F naught upon EP dash. So, if I multiply F naught over here, right? F naught times 1 upon EP dash, it's a negative sign. I'll get the required magnification. That is what I want to do. So first I'll multiply F naught guy over here, right? So minus and then minus. So I'll have F naught FE plus D bring this F naught outside. What you'll get is minus F naught by Fe, F subscript E essentially. When I say Fe, F subscript T, focal length of the eyepiece. Now I have taken Fe outside. Now D would be easily divided. D would be 1 plus. You may straight away pause it, the video, rerun it from this point if you're not clear with it. Fe is taken outside. If you take Fe outside, you're left with Fe plus T by D. D by D becomes 1. Fe by D is this thing. Now this is the magnification which we were after, because this is the guy. Now use this quantity straight away in here, right? If you use that, your M would be coming to be equal to minus FO by Fe, ratio of focal lengths of objective and eyepiece, into 1 plus Fe by D. And this is the case for your, as discussed earlier, this is known as D adjustment, or the case when the image is perceived to be at the least distance of distinct vision. D adjustment. Now, what about the length of the tube? That is FO plus EP dash. EP dash here is this quantity, FED by Fe plus D. So if you use this thing over here, straight away coming to here, right? So using this and this, you can get length of the tube is equal to FO plus FED upon Fe plus D. I've just used this thing on here and got the value. So this gives you the length of the tube for D adjustment. What is D adjustment? This guy is your D adjustment, magnification, length of the tube. For normal adjustment, magnification, length of the tube. Now, again, just come back to this. For normal adjustment, this has to be Fe. And for the case of this diagram, it is not under normal adjustment, it is under the D adjustment, when I'm perceiving the image to be located at the least distance of distinct vision, which is capital D. This is the EP dash value for calculating length of the tube. This is 1 upon EP dash value, which is used for the magnification of the astronomical telescope. So these are two values which you should be aware about. And again, approximation is that the object is very far away. And for that situation, alpha equals tan alpha, beta is equal to tan beta. And keeping all these things into mind, this pretty much sums up the idea about telescopes. And this completes the topic of geometrical optics over here. We started from the treatment of rays, or rather treatment of light as rays. And those rays are perceived by my eyes as traveling in a straight line. That is rectilinear propagation of light. And that built on to give me reflection, refraction. Then we talked about reflection in detail, then refraction in detail, then mixed both of them. Then we made use of lenses to understand what refraction is about. Then when is the lens converging, when it's diverging. Then we introduced human eye. And to produce a magnified image, we need optical instruments, which magnifies or increases or enhances my visual angle. Greater visual angle, more number of rods and cones activated on the retina, and higher the image dimension. And for that requirement, or for that pursuit, I need a simple or a compound microscope for perceiving closer objects, and an astronomical telescope for seeing faraway objects like star, sun, or anything like that.